Hey everybody, so this is the second video of Newton's law of universal gravitation. So the only thing that we covered in the first video was kind of just the nature of gravity, which is all things with mass attract everything else with mass. So if you're here on Earth and there's some star in a galaxy far, far away, it still exerts an attractive force on you, and you still exert an attractive force on it. Now, the last thing in Newton's law of universal gravitation that we're going to talk about is how to quantify this force. So how strong is this force? And so Newton developed an equation. The force of gravity is equal to a constant, big G is how we write it for short, times the masses of the two objects, mass 1 and mass 2, which can go in any order, divided by the distance between them squared. So G is just a number. It's just always 6.67 times 10 to the negative 11 newtons times meters squared over kilograms squared. So whenever you see big G, you just put in this number. Always the same. It's the universal constant of gravitation. And we just write G so we don't have to write this out all the time. It's just shorter. And then M1 is just the mass. So in this example, this could be the mass of you. This is your mass. And M2 we could say is the mass of the star. And R is the distance between you. And something important to remember is just to be mindful of your units. So the mass will always be in kilograms, and the distance will always be in meters. So if it's not in meters or if it's not in kilograms, remember to convert it first. And the reason is that big G is set up so that when you multiply M1 and M2, you're going to get kilograms squared as a unit, which will cancel out with these kilograms squared on the bottom of big G. And for R squared, you'll get meters squared, which will cancel out with these meters squared on top of big G, which will leave you just with newtons, which is what we want because newtons are a unit of force and the force of gravity is a force. So let's just throw some random numbers in here and get a number. So we'll say that your mass is 60 kilograms, and we'll say the mass of this star is 8.2 times 10 to the 48 kilograms. And let's say the distance between you so the distance between you guys is 7.4 times 10 to the 80 meters. Alright, so we're all set. Now we have everything we need to know to figure out how strong the force of gravity is that's attracting you to the star and the star to you. So we're just going to plug these values right into the equation. So G is always the same. So I'll just write it out in its long form. 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. And then we need to multiply it by the two masses. So let's do your mass first. 60 kilograms. Now the mass of the star is 8.2 times 10 to the 48 kilograms. And now we just need to divide by the distance between you squared. 7.4 times 10 to the 80 meters. And that's this whole distance squared. Alright, so if you plug that into your calculator, let's see, you should get something like 6 times 10 to the negative 122nd newtons. So this is a really tiny number, which makes sense because you don't experience in your everyday life being kind of torn apart by the force of gravity from every single thing around you. So it's good that some of these forces can be quite small and negligible even. Times 10 negative 122 is quite small.